Okay, this is activity 22 notes, and what we are doing is we are solving systems of equations with 3 variables. Now, last class in 21, we were doing systems of equations with 2 variables, and I stressed highly the importance of using elimination instead of substitution, and the reason for that is today's lesson. So we want to get used to that whole elimination process. So when I start these, I'm just going to kind of name these. This is equation 1, this is equation 2, this one's equation 3. And what we're going to do is we're going to take 2 of these equations and try to eliminate one variable. And then we're going to take the third one that we didn't use, and then one that we used, and then combine those in a way to eliminate the same variable. It doesn't matter which variable you eliminate first. I just kind of look at the equation and decide maybe which one I'm going to look at. And so here's this whole thought process. So here in equation 1, I have a positive 2x. And here in the bottom, I've got a negative 10x. So in order for me to combine those two and get those x's to go away, I'm going to take number 1 and I'm going to multiply it by 5. This is a scalar of 5. So what that looks like is if I took this whole thing right here and I multiplied it by 5, I'm going to distribute this 5 and everything there on the inside. And what I'll do is I'll just write that down here. So I've got 10x, and then I've got 5 times the y, which gives me a positive 5y. And then a 5 times z, which is a positive 5z. And then lastly, it's going to equal 3 times 5, which is 15. So as I combine those, the x's go away. I'm left with y plus 7z equals negative 5. That's great. I've eliminated one of them. So I'm going to write that up here. And I cannot stress enough how important it is to double check all your signs here, like as I'm struggling to write this down. And just double check your math and this simple adding and subtracting, because if we mess something up, it's going to mess up a lot of things. Okay, so I used number 3 and I used number 1. So I did not use number 2. So I have to use number 2. I'm going to rewrite number 2 down here. So I got negative 14x minus 3y plus 3z equals negative 23. And I need to take either 1 or 3, change it, so that I can get rid of the x values again. It's going to be easier for me to change 1, equation 1. So if I changed equation 1, and to get that 2 to be the opposite of the 2x, or the 2x to get the opposite of negative 14, I need to times this by 7. So I'm going to distribute that 7. So this one is just number 1. And once again, I'm timesing, but instead of timesing by 5 this time, I'm timesing it by 7. So it's going to give me a 14x, and then plus 7y plus 7z. And that's going to equal 21. I can combine those. Whoops. That's going to give me a 4y plus 10z equals a negative 2. So now I have this equation that has a 4y plus 10z equals negative 2. And now I have 2 equations with 2 variables. So this is basically the same thing that we were doing in activity 21. So now I can times this. I'm going to times this one by a negative 4. I'm going to write it down here. I got negative 4y minus 28z equals a positive 20. As I combine those, it's going to give me an negative 18z equals a positive 18. Then I can get the z by itself. I'm going to divide this by negative 18, divide by negative 18, and z is going to equal negative 1, which is awesome. Okay, what my answer is going to look like, it's kind of an ordered pair, but it's going to have an x, a y, and a z value. And I have just found my z. Okay, so what I can do is I can take that z and I can plug it back into one of my equations up here. So I got 4y plus 10 times -1 equals -2. You can plug it into either one of those two equations. So I got 4y minus 10 equals -2. I'm going to divide by, well, not divide yet. I'm going to plus 10, y equals 8. Oh, 4y. Divide by 4, y is going to equal 2. And so in my answer, I can put my 2 up here. And then, because I have 2 of the variables, I just need my x. I can use any one of my 3 original equations, plug in those 2 values. So I'm just going to stick with 1. He's been treating us pretty good. So I've got 2x plus 2, because that's my y value. And then I'm going to add my -1, which is my z value. And that is going to equal 3. So we've got 2x, 2 minus 1 is 1, plus 1 equals 3. We're going to minus 1, 2x equals 2, divide by 2, and x is going to equal 1. So final answer on this one is going to be 1, 2, -1. So we're going to combine 2 of the functions, and then we're going to combine the third function that we didn't use with one of them, and might have to multiply a few things. Sometimes we might have to multiply both of them, but eventually we're going to get down to 3 answers. Now, I have done this assignment. This is the 3rd time I've gone through the whole assignment. So I've tried to get as much experience with it as I can. I have not seen any answers that are fractions. They've all been whole numbers. So if you get down to where you get a variable equals a fraction, there's probably a mistake somewhere. I just haven't seen any of those yet. Okay? All right. That's a lot, but let's go. We're going to do a few examples here. This is another example of something that may come up in your problem. And you'll see a few of these. So what we're doing is you can work this problem out the same exact way. If you don't want to, that's fine. You have an x value, a y value, and a z value. So what you need to do is just plug it in and see if those 3 answers hold true for all 3 equations. They may work in 1, they may work in 2, but if they don't work in the 3rd one, then it's not a true answer. Okay, so you can just work this out a few times in your calculator. So I got a -5, and then I got a -1, -2, -6, then -4 is a 5 there, and that should equal -9 if this is true. So I got 5 plus 12, and then minus 20, that's 17, minus 20, it's going to give me -3. That does not equal -9, so it's not the first one. Okay, so let's try this with the next set of numbers. So if I plug that in, I've got a -1, I've got a 1, I've got a 3, so it's 5 minus 2 minus 12. 5 minus 2 is 3, minus 12, it's a -9. That does equal -9. So far that holds true for the second one, but we have to plug it into all of them. Get a different color here. So then we got -2, -1, minus 5, and instead of y, we'll plug it in 1, and then plus 3, and that should equal 21. So I got 3 minus 5 plus 3 equals 21, and that is -2 plus 3 is 1 equals 21. Well, that worked for the first one, but it didn't work for the second one. Now, I know the answer is the last one because I've done this one already. So I'll just kind of prove that and kind of show you that I'm just erasing my inputs here, so I'm going to have to rewrite the entire equation. And so if I go in and I plug in a 1, -4, and a 3, 1, -4, and a 3, and I'll do it with the third one, I'll get -5 plus 8 minus 12 equals -9. -5 plus 8, that's going to give me 3 minus 12 equals -9. -9 equals -9. True statement. I got -2 plus 20 plus 3 equals 21. 18 plus 3 equals 21. 21 equals 21. And lastly, got -2, and then I'm plugging in 1, minus 5, and I'm plugging in a -4, and then minus z, which is 3, equals 15. -2 plus 20 minus 3. That's going to give me 18 minus 3, so 15 equals 15. So when I plugged these ones in, it was true in all of them. Now, you may find it easier to just solve like we did in the first one rather than plugging in each one. And that's great because it'll work. It'll give you the exact answer you need. You might get to where, like if I look up here, if I get, let's say I get z first, or let's say I get y first, and I notice that, hey, there's only one answer that has a -y, or -4 is a y, well, that's my answer. I don't even have to do the rest of them. Okay, let's do another one. This is another thing that we might come across. So what it's asking is if I have one solution, which would be the x, y, z, or if you have no solutions, to where if you get like an incorrect statement, like a 5 equals 3, or if there's infinitely many, where you get like a 0 equals 0. It's usually what it ends up being is 0 equals 0, but it doesn't always. So we're going to start it off the same way. We are going to, let's just take number 1. Let's see. We've got number 1, number 2, number 3. If I were to take number 1 and times it by -2, and then combine it, or let's just do a -4, because then I can combine it with 3. So this is number 1, and I'm times it by -4, and I combine it with 3 just because it's on the bottom. It makes it a little bit easier. I get a -12x minus 4y plus 8z equals +8. Now double check my math here. 4, -4, +8. Okay, so as I combine, I'm going to get the x's cancel out, and I've got -6y, the -2z, positive, so plus 6z, and that's going to equal 6. So I'm going to write this up here. So I got -6y plus 6z equals 6. So I used 1 and 3, so I need to use 2. So once again, I'm going to take number 1 on this second go around. Let me get a different color. I'm going to go number 1. And I am going to times it by a -2. So -2. So that's going to give me a -6x minus 2y plus 4z equals 4. And then I'm going to use just number 2, which is right here, which is 6x minus 4y plus 2z equals 2. And when I combine them, I'm going to get -6y plus 6z equals 2. And this is interesting. This is where we get some interesting stuff. We're going to get -6y plus 6z, does that look familiar, equals 2. This thing right here is exactly the same. If we have solutions, they better equal the same thing. And they don't. Top one equals a 6, the top one equals a 2, so I know that this has no solutions. And to kind of prove that, I could go through, change the sign of the upper one, times it by -1. So that would give me that 6y minus 6z equals negative 6. Combine those, I'd get 0 equals negative 4. No solution. And if you get that at any point, it's a no solution. Okay? All right, let's do another one of these. Okay? This is one that we're plugging our x, y, and z values. And this time we only have to test one pair. Remember, if it works in the first one, it's got to work in the second one, and it has to work in the third one. If at any point you get a statement that's not true, then there's no solution, or it's not a solution. Doesn't necessarily mean that there isn't one. I have found on these that it's usually the third equation that makes it not true. So pro tip, start with that one. Just because the third one's true doesn't mean the other two are, but it's usually where I found that it makes the mistake first. So what I'm going to do is I'm going to go negative 4 instead of x plus 2 instead of y minus 5, and equals negative 41. And I'm plugging in a negative 1, negative 5, and then a 7. So 4 minus 10 minus 35 equals negative 41. Negative 6 minus 35 equals negative 41. Negative 41 equals negative 41. That's a true statement. So far, it's working. Like I said, just because this one's true doesn't mean all of them are. We do have to check each one of them. So let's just go to the second one. Negative 3 plus 3, and then y plus z equals negative 5. Let's plug in again 1, negative 1, negative 5, and 7. So 3 minus 15 plus 7 equals negative 5. Gives me negative 12 plus 7 equals negative 5. Negative 5 is equal to negative 5. So this one holds true. And let's do the last one. We'll do it up here. So we got minus 5y minus 4z equals negative 4. And we'll choose orange. So negative 1, negative 5, 7, so negative 1 plus 25 minus 28 equals negative 4. So this would be 24 minus 28 equals negative 4. Negative 4 does equal negative 4. And so this last one holds true. So this one is a yes. Like I said, it might be easier for you to actually solve the equation and see if you get those three answers. If that's the case, then great. Once again, if it gives us some options, we can just plug them in. I mean, yeah, it takes a second, but it's something that we've done a lot of. Just watch your signs. Make sure you put it in your calculator correctly. Okay, this is kind of the last example. This is a word problem. And all the word problems in this one have been pretty similar. And so it gives us the sum of measures of angles of a triangle is 180. So here we're working with x, y, and z. So what that tells me, if I take x plus y plus z, that's going to equal 180 degrees. And that's a given. That is every single triangle in the world, if you add up the three angles on the inside, it'll always equal 180. Just one of those geometry always things. Okay, the second thing it says is the sum of the measures, and we're going to call this is angle 1, this is angle 2, this is angle 3. Just kind of keep track of stuff. Okay, the sum of the measure of the second and third angle, so if I take the second and third angle, y plus z, is 5 times the measure of the first angle. So I have to take the first angle, times it by 5 to get it to be the sum of the first two. Okay? This isn't a form that we're used to yet. It's all right. We'll work with it. Okay. The third angle, z, is 26 more than the second. So I know that z equals the second one plus 26. Okay. We have three equations. It's not in the form that we're used to. We're used to seeing in this x plus y plus z equals some number. And this is the form that we need to get it into. So the first one is already like this. So that's done. But I'm going to have to mess around a little bit. So I'm going to minus 5x, so I've got negative 5x plus y plus z equals 0. It's okay for it to equal 0. It's great. Okay, this last one, I'm get a minus y, and I'm going to leave the 26. So I've got a negative y plus z equals 26. I want that constant out on that right-hand side. Now what I'm going to do is I'm going to line these up and work with them in order to get rid of one of the variables. So I'm going to rewrite these. So I got x plus y plus z equals 180. Got the second function, which is negative 5x plus y plus z equals 0. And then the last one, I've got negative y plus z equals 26. Now, if we notice, this third function already is missing an x. So I got number 1, number 2, and number 3. So that's awesome. So what I can do is take the first two. So if I take this first one, and I take this and I multiply it by 5, it's going to give me a positive 5. I'm going to be able to get rid of my x's. So I got 5x plus 5y plus 5z equals 180 times 5. It's 2.5 spins. Should be 900, but let me double check on my calculator. Times 5 is 900. Okay, and then I'm just going to write down the number 2 again, which was negative 5x plus y plus z equals 0. Add these together, 6y plus 6z equals 900. Now, I have function without an x, a function without an x, or equation. So I'm going to go negative y plus z equals 26. That was the first one. And then 6y plus 6z equals 900. Now, I'm going to take my first one. I'm going to multiply by 6. So that's going to give me a negative 6y plus 6z equals 26 times 6. 156. Yeah, we're getting some big numbers. That's all right. But that allows me to add these two together. So the y's go away. So I got 12x plus 1. Oh, it's not an x either. Careful. Z equals 1056. Divide by 12. Divide by 12. And I get 1056 divided by 12 equals 88. Okay, now that I know one of them, I can plug that back into, let's just say number 3 here. Plug my 88 in here. So I got, let's get it kind of, I'm going to come down here with it. So I'm going to go, so negative y plus 88 equals 26 minus 88. Minus 88, wow. Negative y equals 26 minus 88 equals negative 62. Divide by negative 1, divide by negative 1, y equals 62. Now I can take both of this x and the y. Well, let's kind of fill out what we've got. It's 88, 62. The first one said that x plus y, which is 62, plus 88 equals 180. Add those two together. Gives me x plus 150 equals 180 minus 150 minus 150. X equals 30. All right, and that is last of those. I am going to upload this video. I'm also going to upload a couple, well, I'm going to put some links for some YouTube videos that I thought were very useful that might go over some different ways of doing things. But if you have any questions, as always, reach out. Send me a screenshot of whatever you're working on. I'd be more than happy. I'm going to have my iPad with me most of the weekend. So I'll probably not get back to you immediately, but send one to me. I'll walk you through it. We'll get it all figured out. You guys are good. See ya.